So on my hot end here is a standard aluminum heat block. And for all intents and purposes, for your typical operation using PLA, ABS, PETG, it's perfectly fine. However, you may notice when looking at your temperature graphs in Octoprint that once you reach your desired temperature, it's not a flat line. Depending on how good your PID tune is, it may kind of wiggle up and down as time goes on. So what I'm testing out right now is this copper block. It is significantly heavier in relation to the aluminum block, but its thermal mass may allow the temperature that I have to be more consistent and stable. Will that result in better printing? I don't know, but I'm surely going to test that. Now, another thing that copper blocks allow you to do is go to extreme temperatures. We're talking well in excess of 300 degrees Celsius, upwards to 450 degrees Celsius. This hot end is not designed to do that, but at some point I may get into exotic filaments like PEEK or PEI that require such temperatures. Now, to do that, you will need a PT100 thermocouple. This particular block does not have the capability to do that, but there are plenty of them out there for less than $10 that do have that. So, for what I have right now, I'm going to test the temperature stability of copper and see if I get better results using it. So we've got the copper on the system, and the interesting thing to see will be the difference between the fact that copper is more conductive with temperature than aluminum is, but it's also got a lot higher thermal mass. With it being installed, we just have to tighten everything down while it's hot. You know, the good old expansion and contraction of metal. So once we do that, we're going to go ahead and test some prints. These are my PID settings before the tuning for copper, so this is tuned for the aluminum block. These are the PID numbers for the tune for the copper block now. Okay, our first layer is down. And I always have my nozzle a little lower than perfect on the first layer, just so I get a little bit of squish so that these tiny details actually adhere, because it retracts on all those tiny little details and has to reprime, etc. So usually by the second or third layer it's perfectly beautifully smooth. So we'll be judging the overall product. So here we got the finished benchy. Gonna pop it off the PEI there. Good old white filaments. Shows us a lot of the spots that might need some improvement. Overall, it's certainly a benchy. So although we're not doing super high temperature printing like you would use a copper block for typically, one of the things that I had a sneaking suspicion would be the case, and according to this graph, it definitely is the case, is the temperature is much more stable. And my only real theory as to why is, in addition to doing the PID tune for this particular block, the block itself being made out of copper has that extra thermal mass. It takes longer to dissipate the heat outside of that copper compared to the aluminum. So because of that, the heater doesn't have to go on and off as crazily fast as it once did. It's just more stable once it reaches its temperature. And whether that results in better prints or not, it's debatable. But when it comes to tuning the system so that everything works harmoniously, I'd wager that stability is definitely something that is worth the $8 it costs to get this copper block.